the very first page here, 4, 5, 6, and 7. These 4 problems talk about stuff that we did way before Thanksgiving break, the Monday and Tuesday right before Thanksgiving break. So this would be 6-1 day 1, 6-1 day 2. If you're looking at notes and need help or have questions, that would be where you would refer to for these 4 problems. Basically, and as I've been trying to tell you, is don't try to make these, for the most part, harder than they need to be. So for example, on number 4, it tells me that EF is the perpendicular bisector of CD. So we know this is a 90-degree angle, and because it's a bisector, it's going to bisect CD. So since we know that this is the perpendicular bisector of CD, what would be true about CE and DE? They're congruent, okay? And like I said, don't try to make them more difficult than they need to be. Now, here's going to be the part that's a little bit tricky, okay? Those two are equal. So we're going to set 4x plus 19 equal to 6x minus 7. And we're going to solve for x. Some of these problems are going to say solve for x or find x. That's what this one does. Once I find x, I'm done. Sometimes it'll say find DE or find CE. So then I got to plug it back in. So really make sure you read the directions carefully, especially on the quiz tomorrow, because that's going to be the part that we got to make sure that we solve and find the right thing. 6 and 7 are more of the angle bisectors, and I didn't give you a ton of these because these are all pretty similar. If we know the 2 angles are congruent, then I know these 2 sides are congruent. If I know these 2 sides are congruent, then I know these 2 angles are congruent. So it's going to be very similar. You're just going to set them equal, solve for x. But on both of those, you're going to have to plug it back in because it's asking you to find an angle or find a length. And so you got to plug it back in to find whatever it's looking for. On the back side of that page, okay, on number 8 through 12, we're doing the circumcenter. Okay, circumcenter and incenter is what we did on Monday. So these are on 6-2, lesson 6-2 notes, if you're looking back at your notes and need some help. Because these are all very, very similar. If we do a couple of these, let's look at like number 9, SY. SY is what I'm looking for, okay? What would SY be the same as? What'd you say? Okay, so, but X is down here though, right? Yeah, yeah, Y, yeah. So these 3, whenever I have a circumcenter, the distance from the circumcenter to each of the endpoints of the triangle will all be the same. Okay. And I know that it looks like a lot of problems, but like for instance on this one, there's not a lot of work involved because once I identify that those 3 are the same, if TY is 14, what do you think SY is going to be? 14, okay? There's really not any work involved there. It's just a matter of identifying that these are congruent and then using that to help me. Now, number 10 is going to be a little bit of work. Number 10 is asking me to find YW. Okay, I can't use this triangle because all I know is 14, and I don't know anything else. So instead of that triangle, I'm going to use this triangle. okay? And so what we're going to do is I know this is 14, and we're looking for this piece here, which is B. If you need to redraw it, you can. So B is representing YW. What do we have that we can use to find B? Pythagorean theorem. Okay. Now here, just be careful where you put everything into the Pythagorean theorem. Notice that this is why I would redraw it, right? Here's my 90-degree angle. And I know it's not marked on here, but we know that on a circumcenter, this is perpendicular right here. So we know this is 90. If that's the 90, then this is my C value right here. So we're going to go 11 squared plus B squared equals 14 squared. Okay. So there's several times on the review where, and on the quiz tomorrow probably, where you're going to have to use the Pythagorean theorem. Okay. Once you have it set up, I think you guys are pretty good at solving that, but if you need some help, let me know. You will get decimals. If there's any problems on here that we get a decimal, round to the nearest tenth, just go to the first decimal place and that'll be good enough. Okay, down here on 13 through 20, these are all in-center problems. We talked about those on Monday as well. Okay, a little bit different, okay? On circumcenter, a circumcenter splits the side in half, okay? An in-center doesn't do that. Like if I look at KL over here, KN and NL are not the same length, okay? On the circumcenter, that's true, but on an in-center, that's not true. The three sides, or the three segments that are congruent here would be MP, PO, and NP. Those are the three that are going to be the same. Okay, and that's something that you have to identify. What pieces are the same? Because I know it here. If I know it's 7 here, then it's 7 here, and it's 7 here. Okay, it's 7 all the way around that triangle. But we got to know what pieces are going to be congruent. So immediately, if I ask you to find out what MP is that going to be hard to do? No, because I already know if PN is 7, then guess what? MP is also 7. If it asks me to find PO, which it doesn't, then we could do that. Now, one that a lot of people struggled with last hour, angle JKP. JKP, the best way to do this one, I think, is to draw the big triangle, okay? When we have an in-center, if this angle is 32, what's the angle right next to it? 32. In-centers are angle bisectors. So we know these two angles are congruent. So this would also be 32. So this whole thing down here would be 64. Same thing over here. If this is 22, the one right next to it is also 22. So the whole thing for that big triangle. Okay, now, we're looking for this angle up here. I can find this angle here, but we're going to have to be careful because we're looking for JKP. I'm doing number 14. JKP is this angle right here. Okay? We're looking for this guy right here. So once I find this angle, what am I going to have to do? Cut it in half. PK is going to split that in half. So once I know this entire angle, I just got to divide it by 2. How am I going to find this angle right here? What do we know about triangles? 180. They add up to 180. Okay, so all 3 angles in there add up to be 180. Whatever's left over is this angle divided by 2 to get half. Okay. So a little bit tricky, a little bit different, but sometimes you just got to look at the bigger picture to help you out. Okay. On this page here, Same thing. You got a lot of problems dealing with circumcenter and incenter. There's a lot of problems dealing with those two. Okay. So these are very, very similar to what we did on the last page. First two groups are circumcenter. The last two groups are incenter. Once again, this was all on 6-2. This was all Monday. Okay. So if you need to go back and look at anything, you can go back at 6-2 and look at some of your notes if you need to. You will need the Pythagorean theorem on some of those. Some of them is just looking at what it is. Like for instance, if I ask you to find QR, if this is 25, what's WR got to be? 25. And so if this is 25 and this is 25, QR would just be 50. Okay. So some of them don't take a lot of time, don't take a lot of work to get there. Some of them will take the Pythagorean theorem. So everyone's going to be just a little bit different based on what we got and what we got to find. This one down here, you're finding some angles, which is a little bit different, but you're doing in-center. Okay, and then the last page, okay, so those are the changes that we're making. I'm going to go through some of these. On the very back, these are the ones that we did yesterday. So 5 and 6 on that back page are the centroid problems. These are the ones that have like the 1/3, 2/3 relationship that we did yesterday. So these are all from 6-3 notes, if you need to go back and look at any notes to help you out. Okay, so let's look at number 5 real quick here. AG is 26. BC is 44. Anytime it gives me a long link like that, I just like to show the whole thing so I don't get confused and think it's like half of it or something. So if that whole thing is 44, then what would FC and FB be? Okay, be half of that. Because the centroid is going to split those in half. Okay, so we know now what FC is, 22. The other piece that they give me is DG is 12. All right, so first of all, let's do that one. DG is 12. This is what we talked about yesterday. Anytime we talk about the centroid, we talk about the 1/3, 2/3 relationship. This is 1/3, this is 2/3. The longer piece is 2 times bigger than the shorter piece. So if this is 12, what's BG got to be? 24. Okay, it's going to be 12 times 2. Okay, if I want to find GF, is GF the shorter piece or the longer piece? It's the shorter piece, okay? So if I know the longer piece, what do I got to do to get back to the shorter piece? You got to divide it, okay? You got to divide it by 2 or take half of it. So this would be 26 divided by 2, or half of 26, which would be 13. If I wanted to find AF is this whole thing, right? So we just keep working through it. If I know this is 26 and I know this is 13, then what would I need to do to find this whole thing? Just add them up. 26 plus 13 is 39. Okay, so that's kind of what you're going through there. You got another centroid problem there as well. So we got a lot of different things. And then back down here, I told you had a lot of circumcenter and incenter problems. On 7 and 8, you're back to circumcenter again. And on number 9, because we're skipping 10, you've got another incenter problem. So lots of circumcenter and incenter, and you got a few centroid problems. We didn't do anything with the orthocenter really, so don't really worry about the orthocenter that we talked about at the end of the notes yesterday. And then there'll be a few things with angle bisector and perpendicular bisector. That's on the very first page. Okay. Questions on any of those so far? Okay, overall,